Have you ever wondered how materials flow under stress? The science that unlocks this mystery is called rheology. It is the study that determines how materials behave when forces are applied to them. This can be a stress applied perpendicularly or tangentially to the surface of the material. Now, imagine a block of butter. If you apply force on it, it deforms and flows. However, if you apply the same force to a steel block, it hardly deforms. This difference in behavior is what rheology helps us understand. But how do scientists measure these differences? One common tool used in the study of rheology is the Brookfield viscometer. This instrument is a rotational viscometer that measures the resistance of a fluid to shear or flow. Here's how it works. A spindle, which is a thin rod, is immersed in the sample material. This spindle is then rotated at various speeds. The resistance to the rotation gives us the viscosity of the material. Different spindles and rotational speeds are used for different viscosity ranges. In some viscometers, the spindle remains stationary and the fluid sample is rotated. This also measures the resistance to movement and thus the viscosity. All these measurements are taken while maintaining a controlled temperature. This is because temperature can influence the viscosity of a material. For example, honey flows more easily when it's warm compared to when it's cold. So to summarize, rheology is the science that explains how materials flow under stress. It uses tools like the Brookfield viscometer to measure the viscosity of materials, which is a key factor in determining how materials will behave under different stresses. From everyday items like butter and honey to industrial materials like concrete and plastics, rheology helps us understand and predict the behavior of these materials. It's a fascinating field that intersects with many others, from food science to geology, from medicine to construction. So the next time you see honey flowing from a spoon or concrete being poured, remember that there's a whole science dedicated to understanding these phenomena. And that science is rheology.